Hello students, today I will be discussing relations and functions. Relations and functions. Relations and functions. In first year PUC, you have just studied the basics of relation and function. But here at present we will be discussing in detail. See, before beginning with relations, let me just write the product A cross B. Consider two non-empty sets A and B. A cross B. A cross B is set of all A comma B such that A belongs to A and B belongs to B. So, A cross B, the Cartesian product of A and B. A cross B is given by set of all ordered pairs A comma B, where A is belonging to A and B is belonging to B. Now, as far as relation is considered, see, we have already studied this. A relation R is a subset of A cross B. A relation R is a subset of A cross B. I will just give you one simple example. See, I will write A is equal to 2, 5 and B is equal to 4, 7. Then A cross B is equal to, so what is A cross B? It is 2, 4, 2, 7 and 5, 4, 5, 7. Now we can define relations on this set A cross B. So I am writing a relation R. So relation R is defined as A is greater than B. The relations are greater than, less than, parallel to, or perpendicular to, congruent to. So all these are mathematical relations. So defined as A greater than B. Now you have to find out those ordered pairs in which A is greater than B. So this is R. You can find only the ordered pair 5, 4. See, you can find 2, 4 here, 2, 7 here, 5, 4, 5, 7. Here 2 is not greater than 4, 2 is not greater than 7, 5 is not greater than 7. So only 5 is greater than 4. Therefore, I can write R is equal to 5, 4. Now, can I say that R is a subset of A cross B? So, a relation is always defined as a subset of A cross B. When we go to this, say second year, syllabus section, we have to learn types of relations. See, types of relations. So we will be discussing different types of relations. See, first we have reflexive relation. Reflexive relation. So what is this reflexive relation? What do you mean by reflexive relation? See, definitions are very important. Generally, you will be getting one mark question on type relations and functions. Most of the cases they have asked definition in the examination. So definitions are important. A relation R on the set A is set to be a reflexive relation if for all, see this symbol represents for all or for every. For all A belonging to A, I am writing A comma A belongs to R. What do you mean by A comma A belongs to R? See, this is just for your understanding. A comma B belongs to R implies A is related to B. This is the meaning. So what do you mean by A comma B belongs to R? A comma B belongs to R means A is related to B. So, when I write A comma A belongs to R, that means A must be related to A. Now, how do you understand that A is related to A? Let us give some example. See, we can give general example as well as set theoretic example. Say, relation, parallel to. I said the mathematical relations which are, some of the relations are parallel to, perpendicular to, not equal, greater than, less than, congruent, etc. So, relation parallel to is reflexive. Relation parallel to is reflexive. What do you mean by this? You take a line, see, set of lines, you take a line, the line is A, okay, you take the line as A. Now, A is always parallel to A. We can always say that the line is parallel to itself, okay. We can always write the line is parallel to itself. So, this shows A related to A parallel to A. What is the meaning here? I said the definition is for all A belongs to A comma A belongs to R. A is related to A. So, I have got A related to A. I'll give you some other example. See, relation, the relation divides is reflexive. Relation divides is reflexive. Why? You can take 2 example, 2 divides 2. So, 2 is A divides A, 2 divides A. Hope you have understood the idea. See, what is the definition? A comma A belongs to R. I mean A is related to A. So, here 2 divides 2. So, that means 2 is related to 2. We can give some examples with respect to this set theory. See, let us take a set A, let it be 1 comma 2, and you write a relation R. Generally, we denote relation by R. Okay, we denote relations by R. Now, let us write the relation. What do you want to write? Reflexive. What is reflexive? A is related to A. So, what are the elements here? 1 and 2. So, 1 is related to 1 comma 1. Then 2 comma 2. Then 1 comma 2. I am simply writing some element. So, here go to the definition. Relation R on the set A is said to be reflexive if for all A belongs to A comma A belongs to R. So, here 1 and 2 are there. So, for all means for every. I will give you one simple example. Suppose in a class there are 10 students. I say the class is the best class if all the students score more than 95 in mathematics. Suppose if 9 students score 100, one student is scoring 94, even then the condition fails. Then the class is not considered to be the best class. Class is considered to be the best class if all the 10 students, all the elements of the set have to satisfy that. So, what are the sets here? 1 comma 2. So, 1 comma 1 belongs to R, 2 comma 2 belongs to R. I will give you one more example. See, A is equal to 1, 2, 3. You take this. Let us consider R. The relation is 1, 1, 2, 2, 1, 2, 1, 3. So, you can't write elements as you wish, but only with respect to the numbers given, these ordered pairs can be written. Now, here R is reflexive. That is true. Is R reflexive here? No. R is not reflexive. R is not reflexive. Why? Because, what did I tell? For all elements belonging to A. But here 1, 2, 3 belongs to A. Therefore, by definition 1 comma 1, 2 comma 2, 3 comma 3 must be present in the set. But here do you have 3 comma 3? Because 3 comma 3 does not belong to R. So, relation is said to be reflexive if for all A belongs to A must be related to A. Have you understood this idea? Hope this idea is clear to all of you. See here, R is not reflexive. I have given an example where R is reflexive and also R is not reflexive. So that means for all elements of the set, A must be related to A. Then R is reflexive. So this is the first type of relation. The second relation is symmetric relation. So what do you mean by symmetric relation? Again, first I will give you the definition. Definition is important. So a relation R on the set A is said to be symmetric. If for all A comma B belonging to A, I said already I have written, this symbol represents for all A comma B belongs to A comma B belongs to R, means B comma A belongs to R. That is what the actual definition. For all AB belongs to A related to B means B is related to A related to B implies B is related to A. I can give you several examples. See, parallel to and perpendicular to, both are symmetric. Why? You take two lines AB, A parallel to B implies, see, A is parallel to B. We can say B is parallel to A. Then we can write the second case, perpendicular. Line A is perpendicular to line B. That means B is perpendicular to A. So what are you actually proving? A related to B should imply B related to A. I can give you some other simple examples. See, is a friend of. Is it symmetric? A is a friend of B implies B is a friend of A. It is not symmetric because A is a friend of B. B need not be a friend of A. Or I'll give you one more example. Is taller than. What about this? Is taller than. Is it symmetric? No. Why? Suppose if I write two persons, A and B. Person A is taller than B. Does it imply B is taller than A? Impossible. So A taller than B means B is not taller than A. That means A related to B means B is not related to A. Therefore, it is not symmetric. I can give you one more example. See, another example. A is the brother of B. Is it symmetric? No. A is the brother of B is not symmetric. Why it is not symmetric? According to symmetric property, what the equation must be or what the result must be? A is the brother of B means B is the brother of A. A related to B means B related to A. Then only the relation is symmetric. But here A is the brother of B. It is not symmetric because B may be the sister of A. So A is the brother of B. It is not symmetric. Why? According to the rule, if A is brother of B, then B must be brother of A. Then only it is symmetric. But even if B is a sister of A, then also A is a brother of B. Therefore, the relation is not symmetric. I can give you one more example. See, I will take the same example now. Let us consider the example, that is, write R as 1 1, 2 2, 1 2, 2 1. See, I can write what are the elements here. How do you write the ordered pair? 1 1, 2 2, then 1 2, then 2 1. Is it symmetric? Yes, it is symmetric. See, 1 1 belongs to R means again 1 1 belongs to R. Why? It is equal. If you say A equal to B, B is also equal to A. Here 2 to 2. If this is equal to this, this is also equal to this. So they are obviously trivially that property holds. But is it symmetric? Yes. Here R is symmetric. 1 2 belongs to R means 2 1 belongs to R. So this is a symmetric. Now I will write another example here. See, A, R is equal to 1 1, 2 2, 3 3. I write 1 2, 2 1, 1 3, 2 3, 2 3. Now read this relation. I have got A is equal to 1 2 3. Now 1 2 2 1, 1 3 2 3. Whether this is symmetric? No. R is not symmetric. R is not symmetric. Why it is not symmetric? Tell me. What is the reason? See, 1 2 belongs to R means 2 1 belongs to R. What about this 1 3? See, 1 3 belongs to R. This implies 3 1 does not belong to R. So observe this point. What is that? 1 3 belongs to R. That means 3 1 is not there. According to the definition, A P belongs to R means B A should belong to R. Therefore, this is not symmetric. So you should know how to give general example and even examples related to these functions. So is the idea clear? So when you study reflexive relation, I am taking only one element. For all A is related to A. When I go to symmetric, I am just relating two elements. There is a similarity, there is a relation between two elements. A related to B means B is related to A. So with the help of this, let us learn the next type of relation. See, that is transitive relation. Hope you have understood reflexive and symmetric. Reflexive means A related to A, because I am giving very simple idea now. Symmetric means A related to B should imply B related to A. Now we go to transitive relation. So what is this transitive relation? See, a relation R on the set A is said to be a transitive relation if for all A, B, C belonging to A, B belongs to R and B, C belongs to R. This implies A, C belongs to R. A, C belongs to R. Now look here, for transitive I am taking three elements. What is the simple idea? A related to B and B related to C implies A is related to C. Now I will just give you one simple example. Don't think like that. See, transitive, there are limitations, restrictions in order to define a transitive relation. I can just give a relation. I love my teacher. Teacher loves his daughter. So I love his daughter. That is wrong. You cannot take it as a reflexive, transitive. So transitive, it has got limitation. See, I will give you an example. Now for example, parallel to, you take the same example. Say, write three lines. Now line A, line B, line C. In the set of straight lines, A is parallel to B, correct? What about B and C? And B is parallel to C. A is parallel to B, B is parallel to C. Can I say A is parallel to C? Obviously, see, A parallel to B, B parallel to C. That means A is parallel to C. Therefore, this relation is transitive. Now, I will give you one more example. Relation, see, general examples, greater than and less than. What about this greater than and less than? Greater than and less than. See, 5 greater than 4 and 4 greater than 3. Does it imply 5 is greater than 3? Yes. See, 5 is greater than 4 and 4 is greater than 3. That means 5 is greater than 3. Therefore, the relation is transitive. Now, 5 is less than 6 and 6 is less than 10. This implies definitely 5 is less than 10. Therefore, the relation is transitive. Why? A greater than B and B greater than C. That means A is greater than C. Similarly, A less than B and B less than C. That implies A is less than C. So, now you go to this example. Let us consider the same example 1 2. Here 1 1 2 2 1 2 2 1. Now, you have to verify whether this is transitive. So, first recall the definition. So, students, always you have to remember, you have to just write and study this definition. You have to at least write once or twice, and while you write the definition, see, that should not be any grammatical error, no spelling mistake, because we will not give you any marks. No mark will be awarded if there are mistakes of that type. So, when you write the definition, it must be a meaningful expression or a meaningful statement. See here, relation R on the set A is said to be transitive. What is the condition? A, for all A, B, C belongs to A. What is that? A comma B belongs to R means A related to B. And this is important. And B comma C belongs to R. B related to C. Then only A related to C. So, if you take this 1 comma 2 belongs to R, and see 1 comma 2, it is an element of set R, and 2 comma 1, it also belongs to R. Now, what do you find? A comma B belongs to R. You compare this. A comma B belongs to R. This is B comma C belongs to R. That means A comma C belongs to R. So, that means 1 comma 1. Don't write directly that it belongs to R. You have to verify whether 1 comma 1 is here. Yes, 1 comma 1 is there in R. Therefore, it belongs to R. So, this is transitive. Don't come to the conclusion like that. You have to verify for all. Say here, again I can write 2 comma 1 belongs to R. 1 comma 2 belongs to R. This implies 2 comma 2 belongs to R. So, now I have taken both the cases. Therefore, it is a transitive. Now, I will write another example, because generally we understand better when we write an example which is not satisfying the condition. See, let us write A is equal to 1, 2, 3. I am writing R is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 1, 3, 3, 1. Well, all of you thoroughly observe this. You have to first read it carefully. What are the elements? 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 1, 3, 3, 1. Okay. Now, one can easily say that this is reflexive. Agree with me? 1, 2, 3 are the elements. So, A comma A, B comma B, C comma C. All the three are there. Yes, reflexive. Is it symmetric? What do you mean by symmetric? A related to B means B related to A. Here, 1, 2 is there, 2, 1 is there. For 1, 3, 3, 1 is there. This is symmetric also. But my question is it transitive? You cannot write blindly. You just verify. For these equal elements, you don't have to verify. You take this 1, 2. First case, 1, 2 belongs to R and 2, 1 belongs to R. So, 1, 1 belongs to R is there. Now, you take the counterpart of this. 2, 1 belongs to R. 1, 2 belongs to R. So, 2, 2 belongs to R. 2, 2 belongs to R. Then, so you observe that because of this, definitely it is there. No, don't arrive at a conclusion like that. You go to this 1, 3 belongs to R. 3, 1 belongs to R. 1, 1, yes. Even third case, this is true. Go to the fourth one. 3, 1 belongs to R. 1, 3 belongs to R. What about this? 3, 3 belongs to R. So can I just, conclude that this is a transitive? Can you just agree with me? No, this is not transitive. See, just if you verify for these 4 is not enough. For all means for every element. Suppose if you take this, see, you take this, 2, 1 belongs to R and 1, 3 belongs to R. Now what do you get? AB belongs to R, BC belongs to R. Now what do you get? 2, 3 belongs to R. Does it belong to R? No. Therefore, it does not belong to R. So, what is the conclusion? Hence, this R is not transitive. See, in 4 different cases, this property is verified. But for one particular case, this is not satisfied. Hence, it is not transitive. Now, hope you have understood this. See, transitive means AB belongs to R and BC belongs to R. Then A, C belongs to R. So, we have this is 2, 1 belongs to R, 1, 3 belongs to R. Then one more question, when can you combine this? Can we just write 2, 1 and 3, 3? Can we write? No, we can't write that, because when you apply this transitive property, 2, 1 means 1 x must be there. So, the next element should begin with 1. Then only you can apply transitive. So, 2, 1, that is, 1 x must be there. Then only we can verify. I can give you one more example. Generally, in your PU level, they have given only one example in the textbook. Only one example is given. That is, they have given one example. X is wife of Y. Whether this relation is transitive. X is wife of Y. Whether the relation is transitive. The relation is a transitive. See, now don't compare this with your general cases. Don't compare it with general. X is wife of Y means Y is wife of X. No, it is wrong. Now, I can just give you another definition for transitive. The other definition is, look at this, for all A, B, C belonging to A, B belongs to R and B, C does not belong to R, implies A, C does not belong to R. This is the other definition for transitive. So, I can define transitive in 2 different forms. That is, A, P belongs to R and B, C belongs to R. Then A, C belongs to R. That is transitive. The other case is, observe this, A, P belongs to R and B, C does not belong to R. Then A, C does not belong to R. Now, just go to this example. See, I am writing X, Y belongs to R. Means what? X is wife of Y. What about this Y, Z does not belong to R? See, when X is wife of Y, Y cannot be wife of somebody. Therefore, Y, Z does not belong to R. This implies X, Z does not belong to R. This implies X, Z does not belong to R. So, I have given you 2 definitions for transitive. Generally, you come across this in the, objective, when you are just working out objective type of questions, you may come across this definition, but in the examination, they have not asked such, examples so far. But since this is given in the textbook, I have just explained this. I can give you one more example. See, set A, 1, 2, 3, 4, 5, 6. Relation R, 1, 2, 3, 5, 4, 6. 1, 2, 3, 5, 4, 6. So, this is transitive. R is transitive. Okay. Why this is transitive? Why this is transitive? 1, 2 belongs to R. Here, if you observe, 1, 2 belongs to R and 2 comma x does not belong to R, implies 1 comma x does not belong to R. See, 1 comma 2 belongs to R and 2 comma x, so 1 comma x does not belong to R. So this is another example. Generally we come across this in some advanced level in the sense when you are answering an objective question, this definition, problems based on this definition may be asked. And moreover, just generally this reflexive, symmetric and transitive. See, board exam you will be getting a 3 marks question on this. You have to prove all the 3. But sometimes in the common entrance test, I mean CET, they have asked earlier, one relation is given, which the given relation is answer A, reflexive, answer B, symmetric, answer C, transitive, answer D, not reflexive. Like that, the answers will be given. In such cases, you need to remember this definition and hence solve the problem. Now, I have defined reflexive, symmetric and transitive. So what do you mean by reflexive? Once again we recall, reflexive for all A belongs to A comma A belongs to R. Symmetric for all A comma B belongs to A comma B belongs to R implies B comma A belongs to R. Transitive for all A comma B comma C belongs to A related to B means A comma B belongs to R and B comma C belongs to R, that means A comma C belongs to R. Now there is a relation called equivalence relation, very very important. This definition was also asked in the exam for 1 mark. Define an equivalence relation, give that statement properly. See, a relation R on the set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. Reflexive, symmetric and transitive. So what do you mean by an equivalence relation? A relation R on the set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. All the 3 must be satisfied. See, again students, when you write these definitions, there should not be any mistakes, because generally much of English is not required for maths, but for definitions grammatical English is required. So you need to write once or twice the statements, the definitions you should remember. Can you give me one simple example? I have already written the examples. In reflexive, symmetric and transitive, you just collect the common example. See, the example is parallel to. Parallel to, I said this is reflexive because line A parallel to line A. Symmetric, because it is symmetric. Why? Line A is parallel to line B, then line B is parallel to line A. Transitive, line A parallel to line B parallel to line C, then line A parallel to line C. Hence, this is an example of equivalence relation. It is equivalence means it is reflexive, symmetric and transitive. Okay, reflexive, symmetric and transitive. See, in the board exam, 100% you will be getting one question on equivalence relation. The question is for 3 marks. 100% will be getting a question on this. I will give you, illustrate this with the help of one simple example. See, the question which was asked in the earlier question paper. Say, first question. Here is a problem, that is, show that the relation R in the set Z of integers given by R equal to set of all AB such that a 2 divides a minus b is an equivalence relation. See, this was asked in the earlier question paper. It's a 3 marks question. You have to show that this is an equivalence relation. First, read the problem carefully. See, solution. What is given? R equal to AB. See, I'll just write this for your understanding. R equal to AB such that 2 divides A minus B. This is already given in the problem. Now, I will rewrite the same problem, that is A comma B belongs to R means 2 divides A minus B. See, I write A comma B belongs to R, that means 2 divides A minus B. Now you have to verify. Okay, first reflexive. If you are getting any confusion, in the side you write down what is reflexive. Very simple. See, A comma A belongs to R. A comma A belongs to R. Now very simple. A comma A, you replace B by A, then what do you get? A comma A belongs to R. That means 2 divides A, you are replacing B by A. So A minus A, what is it? 0. Remember, 2 divides 0. Can 0 be divided by any number? Yes. 0 by 2, 0, 0 by 3, 0. Does 0 divide any number? No. It is not defined. So 0 is divided by any number. Therefore, 2 divides 0. This implies, can I write 2 divides this 0? See, first keep this idea in mind. What do you mean by reflexive? A comma A should be there. So, A comma B means 2 divides A minus B. If it is B here, here B. Now I want A minus A. So 0 is the same as A minus A, no? I am not bringing any new idea. See, we know that 2 divides 0. Now, 0 is nothing but A minus A. Now, just compare. 2 divides A minus B means A comma B belongs to R. Agree with me? Now, 2 divides A minus A. Here, A minus A. Therefore, obviously, this ordered pair should become A comma A. So, that means A comma A belongs to R. Now, just to refer to the definition, what is your reflexive definition? For all A comma A belongs to R. A comma A belongs to R. So, A comma A belongs to R. Therefore, R is reflexive. Have you understood the method? Here, first I am writing I want A comma A. What is needed? I want A comma A. Why? My reflexive relation says A is related to itself. Now, second case, I am writing A comma B belongs to R. Okay, write the definition. What is given in the problem? Copy the same problem. A comma B belongs to R. What does it imply? 2 divides A minus B. Okay. Now once again, recall your definition. What do you mean by symmetric? A comma B belongs to R means B comma A belongs to R. You want to prove this. So I have got 2 divides A minus B, right? Now you go to the theory of divisibility. I write 2. See this vertical line, I am just representing it as divisibility. 2 divides 4, correct? Don't say this is 2 by 4, that is your computer language, but mathematically 2 divides 4. 2 is dividing 4. What is the meaning of this? 4 is divided by 2. That is the meaning. So 2 divides 4, correct? 2 2s are 4, so 2 divides 4. Can I say 2 divides minus 4 also? Yes. When 2 is dividing plus 4, obviously 2 should divide minus 4, because 2 into minus 2 is minus 4. So now come to this. I need the same concept. Hope you have got this. A divides B means A is dividing minus B. Now 2 divides A minus B. That means 2 divides minus of A minus B also. Minus of A minus B. Why? 2 divides 4. 2 divides minus 4. 2 divides A minus B. One full term. So 2 must divide minus of that. Now this is 2 divides minus of A minus B. Now open the bracket. Minus A minus into minus plus. Is it correct? 2 divides B minus A. Now all of you read the definition again. Please read the definition. 2 divides A minus B. Then what do you have? A comma B belongs to R. Now 2 divides B minus A. B minus A. A minus B means first element is A, second element is B. B minus A means first element is B, second element is A. Therefore your ordered pair becomes B comma A belongs to R. Follow the point? Now does it prove that it is a symmetric? Yes. See, AB belongs to R. I got BA belongs to R. So AB belongs to R means BA belongs to R. Therefore the function is, the relation is symmetric. Now let us verify the third one. Just look at this. We have A comma B belongs to R implies 2 divides A minus B, and B comma C belongs to R, 2 divides B minus C. Okay. What do you mean by transitive? Transitive, recall the definition. A comma B belongs to R means B comma C belongs to R. Then A comma C belongs to R. See, I am writing A comma B belongs to R. Definition is there. B comma C belongs to R. 2 divides B minus C. Now once again recall. See, we have 2 divides 4. Agree with me? Yes. 2 divides 8. Correct? See, always 2 divides 4. Always 2 divides 8. Can I say 2 divides 4 plus 8? Definitely. See, what is 4 plus 8? 12. And 12 is divisible by 2. Therefore 2 divides 12. So 2 divides 4 and 2 divides 8. 2 divides 4 plus 8. I am giving a general idea. A divides B and A divides C. A divides what? B plus C. Now what do you find here? What do you find? 2 divides A minus B and 2 divides B minus C. Compare with this. This is A, this is B, this is A, this is B. So A divides B, this is A divides C, you take it as C. So A should divide B plus C. The definition is here. Therefore 2 divides A minus B plus B minus C. Agree with me? 2 divides A minus B and B minus C. What is it? Cancel this B. Now this is nothing but 2 divides A minus C. Agree with me? 2 divides A minus C. Now go to the definition. All of you read the definition once again. 2 divides A minus B means A comma B belongs to R. 2 divides A minus C, that means A comma C belongs to R. So what is the conclusion? This is a transitive. So I have verified that this given problem is reflexive, symmetric and transitive. Hence the relation is an equivalence relation. So final conclusion is very important. When we, a word mark for this, see, 1 mark for this step, 1 mark for writing this symmetric, and 1 mark for the final one. Okay, so this is a 3 marks question. See, I'll give you another example. On the set Z of integers, I am writing a relation R as x comma y such that x minus y is an integer. X minus y is an integer. See, even this is a question which was asked in the earlier question paper for 3 marks. Now, you have to once again, as I have explained earlier, once again you have to verify reflexive, symmetric and transitive. Okay. Now, what you have to do first to tell me? Generally, when problem is written in this form, it becomes quite difficult to understand. So, you better write x comma y belongs to R means x minus y is an integer. X minus y is an integer. Now, first reflexive. See, reflexive means x comma x belongs to R, correct? X comma x belongs to R. So, x minus y is an integer. I am writing, see, x comma x means what? According to this definition, what is that? X minus x means 0. So, 0 is an integer, correct? 0 is an integer. That is, x minus x is an integer, correct? 0 is an integer. 0 is an integer means what? X minus x is an integer. See, why we write that? How do you write that 0 is an integer? How do you know that you have to write that also? That is, x comma x belongs to R. So, x minus x is 0. That's why I am writing 0 is an integer. That means x minus x is an integer. That implies x comma x belongs to R. Now, read this. See, x comma y belongs to R. X minus y is an integer. Now, what do you have? X minus x is an integer. Therefore, x comma x belongs to R. Okay. That means x comma x belongs to R. So, x comma x belongs to R. Therefore, R is reflexive. R is reflexive. Now, second case. We have x minus y. First write x comma y belongs to R means x minus y is an integer, correct? X minus y is an integer. Now, observe, 2 is an integer. I am writing 2 belongs to z. 2 is an integer. This implies minus 2 is also an integer, correct? 2 is an integer. So, what is minus 2? It is also an integer. Therefore, I am writing minus of x minus y is an integer. You have understood the point? I said 2 is an integer means minus 2 is an integer. So, x minus y is an integer means minus of x minus y is an integer. But what is this? What is this? Minus of x minus y. See, open the bracket. It is y minus x. Y minus x is an integer. Now, you go to the definition. X comma y belongs to R. What is that? X minus y is an integer. X comma y belongs to R. X minus y is an integer. Now, you look at this. First element is changed to y. Second element is replaced by x. That means y comma x is an or y comma x belongs to R. Why? X comma y belongs to R. I got y comma x belongs to R. Therefore, y next. I will just explain the transitive. See, what is transitive? We can write the third one is x y belongs to R. X minus y is an integer and y comma x belongs to R. Y minus z is an integer. Y minus z is an integer. Now, remember the point. 2 is an integer. 5 is an integer. Can I say 2 plus 5 equal to 7 an integer? Sum of 2 integer is an integer. Therefore, sum of 2 integer is an integer. Hence, you can write x minus y plus y minus z is an integer. X minus y plus y minus z is an integer. Now, what about this y? Cancels. So, x minus z is an integer. Correct? Now what is the conclusion? Go to this. Xy belongs to R. X minus y is an integer. Now x minus z is an integer. Therefore it is x comma z belongs to R. So what is that? X comma z belongs to R. So we have written, see, x comma y belongs to R, y comma z belongs to R. Now what do you find? X comma z belongs to R. What is the conclusion? R is transitive. So I have verified R is reflexive, R is symmetric, and R is transitive. Hence R is an equivalence relation. Okay? Understood the point? R is an equivalence relation.